Here are more examples for the data science vocabulary terms. K-means clustering, an unsupervised machine learning algorithm that partitions data into clusters based on similarity. Example, using K-means clustering to group customers based on their purchasing behavior in an e-commerce store. Support vector machine, SVM, a supervised machine learning algorithm used for classification and regression tasks. Example, using an SVM to classify images of handwritten digits into their respective numbers, 0 to 9. Feature selection, the process of choosing a subset of relevant features to improve model performance and reduce complexity. Example, selecting the most important features for predicting stock prices, such as trading volume and market sentiment. Hyperparameter tuning, the optimization of hyperparameters, parameters set before model training, to achieve better model performance. Example, tuning the learning rate and the number of hidden layers in a neural network to improve accuracy. Model evaluation, the assessment of a machine learning model's performance using metrics like accuracy, precision, recall, and F1 score. Example, evaluating a natural language processing model's accuracy in sentiment analysis by comparing its predictions to human ratings. A/B testing, a statistical method used to compare two versions, A and B, of a product or web page to determine which performs better. Example, testing two different website designs to see which one results in more user signups. Root mean square error, RMSE, a common metric used to measure the error or accuracy of regression models. Example, calculating the RMSE to assess how well a housing price prediction model performs compared to actual prices. Confusion matrix, a table used in classification to visualize the performance of a model by showing true positives, true negatives, false positives, and false negatives. Example, analyzing a confusion matrix to understand the performance of a medical diagnostic model for a disease. Precision and recall, metrics used to evaluate the performance of classification models, particularly in cases with imbalanced classes. Example, in a medical diagnosis model, precision measures the accuracy of positive predictions, and recall measures how many actual positives were correctly predicted. ROC curve, receiver operating characteristic, ROC, curve is a graphical representation of a classification model's performance at various thresholds. Example, plotting an ROC curve to evaluate the trade-off between true positive rate and false positive rate in a fraud detection model. Feature importance, a measure of how much a feature contributes to a model's predictions. Example, determining that a customer's credit score is the most important feature when predicting loan approval. Gradient descent, an optimization algorithm used to minimize the error of a model by adjusting its parameters. Example, using gradient descent to optimize the coefficients of a linear regression model. Regularization, techniques used to prevent overfitting in machine learning models by adding penalties to certain parameters. Example, applying L1 or L2 regularization to a neural network to prevent excessive weight values. Time series analysis, the study of data points collected or recorded at specific time intervals to identify patterns and make forecasts. Example, analyzing historical stock prices to predict future price movements. Anomaly detection, identifying rare or unusual patterns in data that do not conform to expected behavior. Example, detecting fraudulent credit card transactions by identifying unusual spending patterns. Ensemble learning, a machine learning technique that combines multiple models to improve predictive performance. Example, using a combination of decision trees, random forests, and gradient boosting to make stock price predictions. Principal component analysis, PCA, a dimensionality reduction technique that transforms data into a new coordinate system to reduce its dimensionality while preserving important information. Example, applying PCA to visualize high-dimensional data, such as facial recognition data. Batch gradient descent, an optimization algorithm that updates model parameters using the entire dataset in each iteration. Example: training a linear regression model using batch gradient descent to find the best fit line. Stochastic gradient descent, an optimization algorithm that updates model parameters using a random subset, mini-batch, of the dataset in each iteration. Example: training a deep neural network using stochastic gradient descent on a large image dataset. Data ethics, the study of ethical issues and considerations related to data collection, storage, and analysis. Example: ensuring that customer data is collected and used in compliance with privacy regulations and ethical standards. Example: ensuring that customer data is collected and used in compliance with privacy regulations and ethical S.